1.4 talks about using the definition of a trigonomic functions. The main term here is reciprocal, and so these are your reciprocal identities. This also is on your chapter 1 formulas. So for all angles theta for which both functions are defined, the following identities hold. So you have sine equals 1 over cosecant, cosine is 1 over secant, tangent is 1 over cotangent, cosecant is 1 over sine, secant is 1 over cosine, and cotangent is 1 over tangent. So if you look here, these are the reciprocal of each other, these two are the reciprocal of each other, and these two are kind of the reciprocal of each other. And so as we move down here, using reciprocal identities, it says cosine of theta given that secant equals 5/3. So what we're trying to find is we're actually trying to find that cosecant. And so I know that cosecant right here is 1 over secant. So I can say cosine of theta equals 1 over secant of theta, which is 1 over secant, and the secant is 5/3. So it's 1 over 5/3. And all we want to do is, this is the same thing as 1 right here. We have the same thing as, let's circle here, 1 times 3/5, because we're going to multiply by our reciprocal, which is going to give us 3/5. So then the cosine of theta is 3/5, which really is the reciprocal of 5/3. So if we move down to our next example here, it gives us, or wants us to find that sine, and it says cosecant of theta is negative square root of 12 over 2. So if I go back up here in sine, if I find sine right here is 1 over cosecant. So if we move back down here to our example B, we know that sine of theta is 1 over negative square root of 12 over 2. Okay, so what we have to do then is we have to take 1 and multiply it times our reciprocal of negative 2 over the square root of 12. Well, I know that the square root of 12 is the square root of 4 times the square root of 3. We can take the square root of 4, which is 2, so this would be 2 to the square root of 3. So then if we come down here, 1 times 2 square root of 12 equals 2 over 2 to the square root of 3. We have to multiply by reciprocal. We can actually cancel these out, so that would give me 1 over the square root of 3. We have to rationalize our denominator, so we're going to multiply that times the square root of 3, or the square root of 3. So our numerator is the square root of 3. Our denominator, when you take a square root times a square root, it gets rid of your square root, which, so your answer here would just be the square root of 3 over 3. So in this section, you're really just dividing by, really multiplying by the reciprocal is a better way to explain it. Moving on to the next page here, we talk about signs of function values. This theta in quadrant 1, 2, 3, and 4 is also on your chapter 1 formulas that you'll want to print off and have with you. So it talks about in quadrant 1 how everything is positive. So sine, cosine, tangent, cotangent, secant, and cosecant are all positive values. If we look in quadrant 2, my only positive values are sine and cosecant. The rest of them are negative. In quadrant 3, my only positives are tangent and cotangent, and the rest of my values are negative. And in quadrant 4, my only positive values are cosine and secant, and the rest of them are negative values. So if I go down the page here a little bit more, it talks about, in quadrant 1 here, I have all positive functions. So from here to here, this is going to be 90 degrees. So from 90 to 180 degrees, we have to look in quadrant 2, which again is up here, so only sine and cosecant would be positive. From 180, we go down to between 180 and 270. In quadrant 3, it talks about your positive and negatives, and then from 270 to 360 is your quadrant 4. And then you go up to your quadrant 4 here and see that only cosine and secant are positive values. As we go down to our examples here, it wants us to determine which angles are in standard position with given measure. So if I think about 87 degrees, approximately right here, so that would be in quadrant 1. So if I scroll back up here to quadrant 1, right here, I know that all my values are positive. So I can go back down, and 87 degrees is in the first quadrant. So all functions are positive. Okay, my next one is 300 degrees. Well, if I think about 300 degrees, approximately about here. This would be about 300 degrees, so that is in quadrant 4. So if I scroll back up to my quadrant 4, it tells me right here that only cosine and secant are positive values. So I can go down and say 300, and say because 300 is in quad 4, that cosine and secant are positive, sine, tangent, cotangent, cosecant, are all negative values. So then if I look at C here, negative 200 degrees, if you think about negative 200 degrees, is you're going backwards. So from here to here is 90, from here to here would be 90, from here to here is 180. So I'm thinking maybe approximately 200 degrees is going to be about here, which would be in quad 2. So if I scroll back up and look in quadrant 2, in quadrant 2 I only have sine and cosecant are my positive values. So if I come back down here to negative 200, because it's in quad 2, I can say that sine and cosecant are positive. Cosine, that's and sine, sorry. Cosine, tangent, cotangent, and secant are negative values. Our next page here, example 3, says identifying the quadrant of an angle. So it says sine of theta is greater than 0 and tangent of theta is less than 0. So what we're doing is we are looking for sine to be positive and tangent to be negative. And so if I drew a little chart here, if I look at my quadrants, in quadrant 1 sine is positive, in quadrant 2 sine is positive, and in quadrant 2 tangent is negative, and in quadrant 4 tangent is negative. And I get those values just from looking at that chart that we just used on the previous page. So I can say since sine of theta is greater than 0 in quads 1 and 2, and tangent is less than 0 in quads 2 and 4, we can say that both conditions only are met in quad 2. So then the answer for that one would be in quadrant 2. If we go down to B and we're looking for cosine to be negative, so you can say here that cosine has to be negative and secant has to be negative also, so we need quadrants where they both are negative. So if I drew another little chart here, in quadrant 2 cosine is negative and secant is negative, and in quadrant 4 cosine is negative and secant is negative also. It's hard to write with little stylus. So I can say that cosine and secant functions are both negative in quads 2 and 3, so theta could be in either of the two quadrants. Okay, if we scroll down our page, it says, are there any quadrants where all 6 trigonometric functions are negative? If you look back, no, there is not. There's really nothing to explain. There is one where they're all positive, but not one with quadrant where they're all negative. Because in quadrant 1, really, all of your functions are positive, so there's no way it can be negative. All right, if we go down to ranges of trigonomic functions, sine and cosine is y such that the absolute value of y has to be less than or equal to 1. The range is between -1 and 1. Tangent and cotangent is y such that y is a real number, and the range is between -infinity and infinity. Secant and cosecant, the range is y such that the absolute value of y has to be greater than or equal to 1, and the range is -infinity, -1, with the union of 1, infinity. That's when these examples will come into play. So example 4 says, deciding whether a value is in the range of a trigonomic function. Decide whether each statement is possible or impossible. So if we look at, whoops, let me move this back up here, sorry. If we look at the sine of theta is 2.5. Okay, so if you were to look back at your previous page, the value of sine, so we could say that A is any value of theta where sine is between -1 and 1. So since 2.5 is greater than 1, A is actually impossible because it is not in the range between -1 and 1. So A is impossible. So if we look at B, B is tangent function can take any real number, and 110.47 is any real number, so that one is possible. If we look at C, secant of 0.6, we say since the absolute value of secant of theta has to be greater than or equal to 1, 0.6 is not greater than or equal to 1, so I could say 0.6 is not greater than or equal to 1, so C would be impossible. So as you scroll back down the page here, it says find all function values given one value in the quadrant. So it says suppose that angle theta is in quadrant 2, and sine of theta equals 2/3. Find the value of the other 5 trigonomic functions. So we know that sine, I'll do it over here, sine of theta is 2/3. We know that sine is y over r, correct? So we know that y is 2 and our r is 3. So we don't know what x is yet, but we know y is 3 and, I'm sorry, y is 2, I apologize, y is 2 and r is 3. Now how do we find what x is? Well, we know to find x we could take x squared plus y squared equals r squared, and we can just substitute our values in of our 2 and our 3. So if I substitute my values in, my value of y is 2 squared, and my value of r, we would be 3 squared, so my x squared is my unknown still. So if I go down, I can say 2 squared is 4, 3 squared is 9, so my x squared is still my unknown. If I subtract 4 from both sides, I can say x squared equals 5. If I take the square root of both sides, I can say x equals plus or minus the square root of 5. Well, remember, we are looking in quadrant 2, so in quadrant 2, where x value actually is, x is negative. So x is going to equal negative square root of 5. So now I can go back over and I can say that cosine of theta is x over r. And I know that x is negative square root of 5. And I know that my r value is 3. So cosine of theta is negative 5/3. My next one I'm going to do is secant of theta is r over x. We know that r is 3 and x is negative square root of 5. Well, we have to rationalize our denominator, so we can multiply times the square root of 5, negative square root of 5 over negative square root of 5, which then will give us negative 3 to square root of 5 over 5. So secant of theta is negative 3 square root of 5 over 5. My tangent of theta is y over x. My y value is 2. My x value is negative square root of 5. We have to rationalize our denominator. So we're going to multiply both our numerator and our denominator by the square root of 5. So my numerator is negative 2 to square root of 5 over 5. So tangent of theta is negative 2 to square root of 5 over 5. Cotangent of theta is x over y. I know my x value is negative square root of 5. My y value is 2. I do not have to rationalize my denominator. So negative square root of 5 over 2 is my cotangent of theta. One more, my cosecant of theta is r over y. I know my r value is 3. My y value is 2. So cosecant of theta equals 3 over 2. Okay, so if we scroll down our page a little bit, it says Pythagorean identities. It says for all angles theta for which function values are defined, the following identities hold. So what I was going to do is give you an example of how each one is true. So it says sine squared of theta plus cosine squared theta equals 1. Well, I know when I am doing trying to find my values, I can say x squared plus y squared equals r squared. So the next thing I can do is I can divide everything by r squared, because r squared over r squared is going to give me my 1. So if I go through and I divide everything by r squared, then what I have is x over r squared plus y over r squared equals 1. And x over r, this right here, is my cosine function, and y over r is my sine function. So then what I have is I have cosine squared plus sine squared equals 1, which is pretty much what I have here, just that sine and cosine are flipped around in the equation. So if I move on to my next one, tangent, I'll plug that one down here. Tangent, I have x squared plus y squared equals r squared. Well, if I look, what is my tangent function? And tangent is y over x, right? So what I'm going to do here is I'm going to divide everything through by x. So I'm going to divide by x squared here, divide by x squared here, and divide by x squared here. Okay? So then what happens is this becomes my 1. Y over x is my tangent function, squared, equals r over x, which is actually r over x is my secant function. So here then I have solved that formula. So if I look down at my next one, I'll go to blue so it's easier right here. I have x squared plus y squared equals r squared. And so really, I kind of did the same thing as over here. We've already solved this once, so I don't need to redo that one for you. We have the quotient identities. It says for all angles theta for which the denominators are not 0, the following items hold. Sine of theta divided by cosine of theta equals tangent of theta, and cosine of theta over sine of theta equals cotangent of theta. So example 6, if I move down the page over here, example 6 says find sine of theta and tangent of theta given that cosine of theta equals negative square root of 3 over 4 and sine of theta is greater than 0. Okay, so what we have to do is we have to find out what sine and cosine equals. So if I say sine squared theta plus cosine squared theta equals 1, I don't know what my sine squared theta is yet, but I can say cosine is negative square root of 3 over 4 squared equals 1. So what I'm doing is I am replacing this negative 3/4 into this value right here. So then I can go down and I can say sine squared plus negative square root of 3 squared is going to give us 3, and 4 squared is 16 equals 1. So if I subtract 3/16 from both sides, this 1 then becomes 16 over 16. So if I have 16 over 16 minus 3 over 16, that will leave me with 11, whoops, not 11, sorry. It looked like a 4 there. It would leave me with 13 over 16. But then remember, I still have sine squared. Sine squared equals 13 over 16. So I have to take the square root of both of these. So this becomes the square root of 13 over 16. Take square root of 16 and I would get 4. So then sine equals square root of 13 over 4. Now what I can do, sorry that's a little messy, now what I can do is I can take my value, my sine of theta divided by cosine of theta equals tangent of theta, because now I have both of my values. So if I say tangent of theta equals sine of theta divided by cosine of theta, and I can just plug those values in, I know that sine of theta is the square root of 13 divided by 4 over cosine of theta, which is negative square root of 3 over 4. Instead of dividing, I'm going to multiply by my reciprocal, so I can say 13 over 4 times negative 4 over the square root of 3. So then this, I can cancel out my 4's, would give me the square root of 13 over the square root of 3. Again, I have to rationalize my denominator, so I can have the square root of 13 over the square root of 3 times the square root of 3 over the square root of 3, which gives me 13 times 3 would be the square root of 39 over 3, and I lost my negative somewhere in the value here. This one should have been negative, so it should have been negative here, which would give me a negative 39, square root of 39 over 3. So then my tangent value is negative square root of 39 over 3. Okay, it says reflect. In example 5 and 6, how are the correct signs chosen when square roots are taken? So if you refer to page 30, then you would know the signs of the functions of the 4 quadrants. Okay, one last example here. It says find sine and cosine of theta given that tangent of theta equals 4/3 and theta is in quadrant 3. And so we have to look, and there is a reason why it's in 3, because if we look, then sine in quadrant 3, sine of theta and cosine of theta will both be negative values. Okay, that's where our quadrants come in. So here, I'm going to say that I'm going to use identity function, and I'm going to say that tangent squared theta plus 1 equals secant squared theta. Okay? Because the reciprocal identity of cosine of theta equals 1 over secant of theta. So that's how I'm going to find my cosine value. And so RE, that's reciprocal, sorry, REC. And that's, so this is why I'm using the secant value. I know that tangent is 4/3, so I can say 4/3 squared plus 1 equals secant squared theta. So if I square 4/3, I will get 16 over 9 plus 1 equals secant squared theta. I have to turn my 1 into 9 over 9 because of my denominator. So now I would have 16 over 9 plus 9 over 9 equals secant squared theta. And if I go down, 16 plus 9 would give me 25 over 9 equals secant squared theta. I would take the square root of both. So here I would get 5 over 3 equals secant of theta. And I know that cosine is actually the inverse, so then I would have cosine equals 3/5. So now I have my cosine value of, it's actually negative 3/5, sorry, because it is in quadrant 3. That's where my negative comes from. So now I can go back up top and I can say, I have my cosine, I have to find sine. So I can say that sine Actually, I'm going to do this in red so it's easier to distinguish. Sine squared of theta equals 1 minus cosine squared of theta, because here you could actually say sine squared theta plus cosine squared theta equals 1. So all I did is subtract cosine squared theta from both sides because I'm finding sine. So really I just skipped one step. So I don't know what my sine value is, so I'm going to say sine squared theta equals 1 minus my negative 3/5 squared. So I'm going to have 1 minus 9 over 25, and I have to take my denominator to change my 1 over 1. So then that becomes 25 over 25 minus 9 over 25. So that would give me 16 over 25. So then sine squared theta equals 16 over 25. I have to take the square root of both. So sine equals 4/5, and because it's in quadrant 3, it's a negative 4/5. So now I have found my sine and my cosine values, which is what it asked me to find up here. So that's it. That is the end of your notes. I hope you were able to follow along. Again, I'll go over any questions that you have in class for next week. The homework is posted in your week 1 folder under chapter 1 homework. So please make sure that is done for next week. If you have any questions, again, email me and let me know. Again, sorry for not being there this week, but I hope all of this made sense, and it's nice that you can go back and re-listen to it if you have to. So have a great week, and if I don't hear from you, I will see you next Tuesday at 6 o'clock, and your homework is due that night, so please make sure that's done. Thanks, and have a great weekend.